Okay. So, ito po, sabi nga kanina doon sa outline ko, practice makes perfect. So this time around naman, let's deal with or let's try to tackle these two examples. So, you have propylene reacting with hydrobromic acid to form 2-bromopropane. So ito po yung top example. And then yung pangalawa namang example po is that you actually have 3-methyl butene reacting with hydrobromic acid to form this species. So sige nga po, paano ba natin i-name to? So when we are naming alkyl halides, we actually we identify the longest chain, which is actually 1, 2, 3, 4. So this is actually gonna be 2-bromo, 2-methyl butane. So yun po. So yun yung product natin. So ang challenge sa inyo, kung meron po kayong pen and paper dyan, try to try to come up or to propose a reasonable and probable reaction mechanism for this. So I'll actually give you siguro a couple of minutes to copy these examples, and then after that po I will be showing you the answer kung paano ba natin nakuha tong reactions na to. So yung first example po natin kanina is involving the reaction between propylene and hydrobromic acid. So yung standard mechanism that I actually showed earlier covers this. So this reaction will start with your pi bond in propylene attacking the electrophilic center, which is this hydrogen atom in hydrobromic acid. And in the process, since it's becoming a hypervalent hydrogen atom, it has to break its bond with bromine to generate what we call a carbocation. But then this time around po, kanina kasi it's very easy. When ethylene reacted, symmetrical po kasi yung the ethylene molecule is symmetrical. So therefore, whichever carbon you attach the hydrogen, wala pong diferensya. It'll just give you the same carbocation. But then in the case of propylene, what happens is that there are two different positions on which you can attach your hydrogen atom or your proton. We typically call it as a proton po, and like for polar reaction. So it can either attach to the terminal carbon atom to form a secondary carbocation like this, or then this can actually attach itself to the middle carbon, generating a primary carbocation. So bakit ba natin tinatawag yan na primary, secondary, at saka po tertiary? So when we classify carbocations based on the number of carbon atoms that are actually attached to your carbocation center. So in this case, I cannot see my camera. Okay, I guess. Okay. So in this case po, you actually are you have the carbocation center, and then we classify it as a primary, secondary, or tertiary depende sa number ng carbon atoms attached to it. So in this particular example, this is your carbocation center, and it has 1, 2, 3 carbon centers surrounding it. So therefore, we classify this as a tertiary carbocation. And then if we remove one carbon and replace it with a hydrogen atom, so in this particular case, it'll look like this. So this carbocation center only has 1, 2 carbons atoms or carbon centers around it. So therefore, since it's only 2, then it's a secondary carbocation. Okay, now if you remove another carbon and you replace it with hydrogen, so this carbocation center only has 1 carbon center attached to it. So therefore, we call it a primary carbocation. So now when it comes to carbocation classifications po, the more carbon centers surrounding your carbocation center, the more stable it is. So yun po. So what I really would want to communicate here is that the most stable amongst the different types of carbocations that can be formed is what we call a tertiary carbocation, because it has 1, 2, 3 carbon centers around it. It's followed by a secondary carbocation which has 1 and 2 carbon centers around it. of these three, the least stable carbocation is a primary one because it only has one carbon atom around it. And bakit po ba ganun? So, ang sabi po natin, a carbocation center is an electron deficient center. So, kulang siya ng electron. So, what happens po is, there's this phenomenon called hyperconjugation. So, hyperconjugation po, it's a way by which carbon centers can stabilize or can partially donate electrons through its sigma bond. So it's a very technical topic, and I will discuss it in a separate session. But then for now, we'll just accept that phenomenon occurs. Like if you have a carbon center attached to a carbocation that can stabilize your electron deficient center. So kumbaga po, analogy nito in real life is that if you have a friend na nawalan or iniwanan ng kapartner, mas madali po kasing kalmahin ang tao na nawalan kapag mas marami siyang kasama, kapag napapaligiran siya ng kabarkada. So kapag tinanggal yung support group ng inyong carbon center na yan or ng kaibigan nyo na nawalan or nasaktan, sino pong kakalma dyan? So it's becoming unstable. So yun po. So when it comes to reaction mechanisms, intermediates that are more stable, sila po yung mas favored na mag-form. So therefore, if your intermediate has a way to form the more stable carbocation, it will do that. So okay, so babalik tayo dito dyan sa example na yan. So what happens here is that your hydrogen attaches itself to the terminal carbon center for you to form the secondary carbocation, again, because a secondary carbocation is more stable than a primary one. And so since it's more stable, its formation is more favored. Yan po ang ifo-form ng nature. So ang nature po talaga ay meron sariling preference. And so since you form a secondary carbocation in this process, what happens is that your bromide ion will end up attacking the electrophilic center that is this secondary carbocation. And so when it does that, the resulting product is this. So what happens is your proton attaches itself to the lesser substituted carbon. Your halide attaches itself to the more substituted carbon. Ito po yung tinawag kanina ni Professor Dindina, Markovnikov's rule. So when you're doing polar addition, say of hydrogen halide compounds across a carbon-carbon double bond, the bromide or the halide will attach itself to the most substituted carbon. So ito po, papakatandaan niyo po yan. Yung hydrogen, dun lagi siya pumupunta sa gilid according to Markovnikov. Dun siya sa less crowded na area. Dun yung gusto pumunta ng hydrogen. So ito po, students and teachers, don't forget about this because this is a very important rule when it comes to proposing reaction mechanisms or even predicting the products for reactions of alkenes. Okay, and so we're actually going to be making this more challenging. So this time around, we are actually using 3-methyl 1-butene reacting with hydrobromic acid. So sabi nga natin kanina, what happens here is that you start with the nucleophilic attack of your carbon-carbon pi bond at the hydrogen center in hydrobromic acid, and in the process, this hydrogen bromine bond will break to form, in this case, following the Markovnikov rule for the first step, a secondary carbocation. So yun po kasi yun. So you form a secondary carbocation. So, but the question is it happy enough? So sabi ko po kanina, if a particular intermediate or if a particular reaction or structure can form a more stable carbocation, it can rearrange. So there's this process called rearrangement that can happen. So ano po ba pag sinabi natin rearrangement, what typically happens is that, so this carbocation is surrounded by how many carbon atoms? So it's surrounded by this carbon atom and also surrounded by this carbon atom. So what happens is, if you would use this as a reference point as carbon number 1, then you have 2 different types of carbon number 2. So either this one or either the one on the left. And so what happens is that one of the groups in your C2 position can migrate to this carbon center to form the more stable carbocation. So for example, if we are to move or if we are to shift this hydrogen atom, kung ilalagay po natin siya dyan sa center, you'll be left with a primary carbocation kasi this carbon center is only attached to one carbon center. But then the other way around, if you would consider the second C2 position to your left, to the left of this carbon, say for example, if we move this hydrogen center over to the carbocation center, what actually happens is you form we will form a tertiary carbocation. So ito po yung process na mangyayari dyan. We call this a 1,2 hydride shift. So this carbon-hydrogen bond, so you move the hydrogen and this pair of electron with it, and you move it, it shifts to the carbocation center. So ano bang resulting structure dyan? Once you do the 1,2 hydride shift, what happens is that you form this tertiary carbocation. So, bakit natin siya tinawag na tertiary? How many carbon atoms are attached to it? 1, 2, and 3. So, if you're going to compare this with the original secondary carbocation, this is actually more stable. And this is actually what's happening in reality. So, once you do this reaction, makikita nyo po is that hydrogen will transfer to the middle carbon of the secondary carbocation for you to form this tertiary carbocation, and it is actually this tertiary carbocation that the bromide ion will attack. So ito na po yung mangyayari. The nucleophilic attack of bromide will happen to the most stable carbocation. So yun po yung tinatawag natin na rearrangement when it comes to reaction mechanism. So these are things that you have to also know. So sinabi niya, kaya po pinapakilala namin sa inyo yung konsepto ng stability. So most stable is a tertiary carbocation. So therefore, nature or your active species will find a way, if possible, for it to form the more stable one. Kasi meron din naman pong mga rules that will not make it possible for things to actually shift. So, gaya nga po na sinabi ko kanina, hindi pwedeng yung hydrogen dito sa gilid ang mag-move dun sa gitna kasi it's forming a less stable intermediate. So you have to be mindful of these rules po when it comes to a rearrangement. So hindi lang po siya proton, even alkyl groups, kahit po methyl group that can actually move to form the more stable carbocation. So ang suggestion ko po, if this is actually something that interests you, you check out, like textbooks po for more examples para mapakita to. And then what I actually plan to do is every once in a while po, I will schedule follow-up sessions po discussing reaction mechanisms for specific types of reactions. Kasi ito, isang type pa lang to ng reaction, nakikita nyo, ang dami na ng mga possibilities. No? So, but what I promise you that we will do later on, ay hindi pa lang po ma-promise kung kailan yung mga follow-ups na yan, hihimayin po natin to this level. We will actually make sure that we actually can come up with analogies that everyone can relate to, and madali nyo pong marirecall. Ano nga yung sinabi ni Sir Jeff na parang analogy when it comes to like our daily experiences, around people na marirelate natin sa reaction mechanisms. Okay, so ito yung homework na ibibigay ko sa inyo, no? And I highly encourage you to post your answers po dun sa ating Facebook page. Try to work on this reaction. Draw a probable or propose a probable reaction mechanism for this reaction. So this is a reaction between an alkene with hydrobromic acid forming the structure that's actually written, that's drawn below. So pakikopya na lang po, and then yung po, paki-post ng answers nyo doon sa ating Facebook page. Ipopost ko tong picture na to doon, and then baka pwede nyo sagutan sa comment section. And I would actually engage with you on that post. Ipapakita ko po sa inyo kung paano po ba ito ginagawa. And who knows, I might actually be able to shoot for a 2 to 3 minute video to actually explain how you end up with that particular structure of a product. So ito may mga alkyl shifts pa rin na nangyayari. So ito po yung challenge problem for that. Okay. All right, so I will be posting this on our Facebook page po, and then at this point, again, I would like to leave you with just these prerequisites po. So reaction mechanism, the types of reactions po that we discussed like from the first part of the discussion. Technically po, kung if you have again a good appreciation of chemical structures, bond polarities, octet rules for formal charges, hindi niyo po kasi kailangan talaga hindi niyo po kailangan mag-memorize sa organic chemistry. Kailangan nyo lang pong i-leverage itong mga basic concepts na natututunan ninyo sa high school. If you take all these basic chemistry concepts to heart, kahit po anong iba tong complex structure sa inyo, alam nyo kung paano magre-react yung mga functional groups na yan. So, hindi po ito actually po, if you study organic chemistry by memorization, hindi po yan masyado magsistick sa inyo. But if you actually learn the art of drawing reaction mechanisms or imagining the transformation of those molecules in your head, yun po kasi that's what we call, like learning things by heart. So kahit po hindi nyo alam yung name ng reaction, ipakita lang sa inyo yung structure, alam niyo na kung anong gagawin dyan. Alam niyo na yung first step. So that's actually how I would like to encourage you all to learn and practice writing organic reaction mechanism. So yun po, we would be happy to answer questions po, but then again at this point I would like to leave you like with these two main prerequisites for you to be able to perfect the art of reaction mechanisms and arrow pushing. Maraming salamat po.